Alright, so as usual, I'm gonna go through the chapter test on the textbook. So, nothing much. Let's start. So first, we're talking about basic function stuff. We have to identify whether it is a function or it is not a function. So let's go ahead and take a look. Right here, we have 2, 3, 7, 9, 2. So for the x value of 2, unfortunately, we have two different y values. What does that mean? That means, unfortunately, this is not a function, because for a function, you can only have one y value. So a is not a function. I'm going to draw an x, and let's do b, c. Okay, so b, 5, 4, 3, 2, 1. Okay, it looks clean. So right there, we can directly confirm, sure, this is a function. Negative 1, 0, 1, 2. So it is okay for two different x value to have the same y value, but it's not okay for one x value to have two different y values. So of course, this is also a function. That works. So now let's state the domain and range for question number 2. So for A, this is very restricted. So our axis goes from -3 all the way to 2. -3 to 2. So that means the domain is x such that -3 is smaller or equal to x is smaller than equal to 2, and x is a real number, right? So that is our domain. And range is even simpler. So range would be y such that 0 is, wait, no, sorry, -4, go to y or equal to 5. And y is a real number. So that is our y, well, our range. For over here, we have the square root function, which is y equals square root of x minus 4. So our domain is x such that x has to be at least, well, it's greater than 0. So x is greater or equal to 0. X is a real number. Y is, so for y, we can see our lowest point is at -4. So we will have y is greater or equal to -4. Y is a real number. So this is going to be the answer. And then for C, it's even more easy. It's just a circle. So x is between 0 and 4, and y is between -2 and 2. And x and y are both a list of real numbers. So that is that. So now we're going to go ahead and plug this in. So this is just plugging in functions. So a f of 5, that's equal to 3 minus 2 times 5 squared, which is 25, minus 50. 3 minus 50, -47. So I'm only going to want to do one of this. Then I'm going to do D, because that's f of 0, so that's a little interesting. So 0 squared 0, -2, so that's just 3. And then I'm going to do a decimal. So 3 minus 2, so 0.5, it's actually, -0.5 is just -1/2. Square that, will have 1/4, so minus 1/2. 3 minus 1/2 is actually 2 1/2. And you can turn that to a improper fraction if you want. And then I'm going to do h, because this is actually evolving in another variable. So many people might be confused, but really, no, it's not hard at all. So this is going to be 3 minus 2, and our x value is going to be 2a minus 1 squared. 3 minus 2, and let's see how this expands out. So 4a squared minus 4a plus 1 minus 8a squared minus 8a plus 2. And then we collect the like terms, so -8a squared minus 8a plus 5. So that is how we expand it with the variable. That is pretty simple. Let's go ahead and do question number 5. Oh, well, 4. So the graph, I'm just going to draw it right away. It's up for you to describe. So this is the square root function. And for 1/x, it's this. And in the middle, there's this asymptote. So x equals 0. Well, sorry, y equals 0. And then x equals 0. There's an asymptote here where it approaches, but it never reaches. Alright, so you guys kind of describe that because these are the only new functions that we introduced here. If you took AP, we're introducing 5 or 6, I believe. And then the graph of f of x is shown. Sketch the following functions. So these I'm going to leave it up to you because it's pretty simple. I'm just going to tell you the translations because I believe we have no problem with sketching. So for A, the entire picture is moved up by 3. And for B, the y values are cut in half, and this entire thing is reflected about the x-axis. And for C, we are flipping about the y-axis first, and then we're giving a horizontal stretch by a factor of 2. So remember the k values, we have to divide by k. And then for D, there's actually two things going on. So we're flipping about the x-axis, and then we're multiplying all the y values by 2. Simple. And then we're gonna flip about the x-axis, and that's it. Sorry, flip about the y-axis, yeah. And then let's go ahead and do this. Describe how each of the following functions can be obtained from f of x. So I'm gonna go ahead and describe the translations. We don't have to draw it, so all we have to do is describe. So for 1, we're moving 4 units up. And for 2, we're moving 2 units to the right and 3 units down. For C, we're flipping about the x-axis, and we're moving 5 units to the left and 1 unit up, 1 unit down. Sorry. For D, we are compressing the entire picture by a factor of 1/3, and then we're flipping that about the y-axis, and we are horizontally compressing it by a factor of 1/3. Plus, we're moving it 5 units up. For E, we are flipping this about the x-axis right away. We're multiplying all the y values by 2. We are horizontally compressing this by a factor of 1/2. We're moving this picture 3 units to the right. Sorry, 3 units to the left. And we're moving this entire picture 6 units up. So that's all the transformations. For F, we are multiplying all the y values by 2. We are factor out the negative from the x, so we're reflecting about the y-axis. And then we're also moving 2 units to the right because we already factored. So it's going to become something like negative x minus 2. This is what it's going to become. And then finally, we're moving 4 units downwards, and that's it. And then let's see, 7. So we just this part, you just have to find the translation and then draw the equation, give out the equation. I will just do it right away. So this one, we move 2 units to the left, 2 units down, and there doesn't seem to be a clear. There's no horizontal or stretches or compressions. So this is just, I believe, square root of x plus 2, and then outside it there's negative 3. Sorry. And these are pretty simple. This is just, you have to do that yourself. Look at the transformations, pretty much easy. This is very easy, a flip, and then I believe there's no compressions or expansions. Yep. So inverse, basically we will move the x to the y and the y to the x. So you can do that on your own because that's just simple math. And then for A, it's a function because that's linear, so of course it's going to be a function. For B, however, it's going to be a picture that looks like this. So no, unfortunately not. It doesn't pass the vertical line test, so no, it's not a function. Sketch the graphs of each of pairs of functions on the same axis. So you can go ahead and do that. That's just asking you to sketch because it wants you to work even better with all the transformations and stuff. 10, the graph y equals x squared is expanded vertically. So we're writing the equation. I'm going to go ahead and do that for you. So we are expanding by factor of 2. So y equals 2x squared. And then we're going to see what's going on. Translate it 3 units to the left. So let's go ahead and fill in here. 3 units to the left, 4 units right. So okay, so I don't need that. So 3 units to the left plus 3 squared, and then we're moving 4 units upwards, so plus 4. And that is pretty much it. So basically our vertex is at -3 and 4, right? -3 and 4. So it'll be somewhere here. So our domain would be x equals a real number. Our range is gonna be y such that y is greater or equal to 4. Y is a list of real numbers. So that is that. Finally, we're gonna move on to my personal favorite parts. Ooh, word problems. So the graph f of x equals to square root of x is horizontally compressed by a factor. Okay, I already did one of these. You guys should be able to do this by now. It's pretty simple. Given f of x equals x squared minus 10x, write the equations for. Okay, so basically that's the first class. So I think you guys should have no problem with that. You will also find the inverse. Okay, no, not the inverse. So you're trying to find the invariant point of these reflections, and then for question number 13, you're doing the same thing. So the only question that I really wanted to talk about is question number 14. So we don't see much word problems these days because we're in a stupid unit, in function unit. So we're gonna actually see a lot of word problem next unit, which is trigonometry, and it's gonna be the hardest unit you're ever gonna see in your mathematical career. Trust me. So let's go ahead and look at 14. Manufacturing. A manufacturing company produces garage doors. The number of garage doors, which is represented by the letter G, produced per week is related to the number of hours of labor. H required per week to produce them by the function of 1.8 times H. So for A, we're just directly plugging it in. So I can't write anymore. A, we're being like G equals. Oh, that's not what I meant to do. G is equal to 1.8. Oh my god. G is equal to 1.8 H. H. Okay, so you know what? We're just gonna plug in the H. I'm gonna do it for you. So if we do square root 500, we're gonna get a 22.36 something. So times that by 1.8, 40.24. So we round it down because it's less than 5. So we round it down so we can produce around 40 doors per week. So use your brain a little bit and be like, wait, can we produce a decimal of a door? No, we probably can't. Maybe you can do it halfway done, but we don't want to do that, so we're gonna say 40 doors. Write the inverse function and explain its meaning. So I'm not gonna write it for you, but because you guys supposed to know how to do it, but I'm gonna explain it for you. So right now we have the doors we're able to produce given the number of hours we work. But then when we have it backwards, we're able to figure out the hours we worked if we look at the number of doors that we produced. So this part in this question, this is actually a pretty useful inverse function because this is often how we calculate work. Well, we calculate wages at many companies. They usually look at worker efficiency. Some companies they look at pure commission and attendance, but many companies they look at efficiency and they will try to use this type of formula to go ahead and calculate how much each worker gets. So then we're gonna do how many labor are needed each hour to keep production at or above 25 hours per week. Okay, so we look at the original functions. We're like, does this really work out? If we set G equals 25, we'll see how many hours it works. So we don't need to use the inverse at this point. Well, it doesn't really matter if you use the inverse, I guess. I don't know. So this is, wow, what is going on? So 25. What? 25 is gonna 25 doors is gonna equal to 1.8. Oh, sorry, no. 1.8 times the square root of h. So let's go ahead and divide 25 by 1.8 first. That's going to give us 13.89988 repeated equals to h. Square both sides. So we're going to get rid of this. So H is equal to 192.9 hours. So therefore, okay, so there might have been something wrong with the inverse. I'm not quite sure. So 192 should be the correct answer. But we're gonna leave this to the next week, and eventually I'm gonna figure out what's going on. And that's pretty much it.